Alright, so welcome to 360. This is organic chemistry, Iipac names of ketones, which is just the nomenclature of ketones. So ketones are carbonyl compounds. So what do we understand by the word carbonyl? So carbonyl compounds are compounds that has a functional group CC with the O bonded like that. I mean C with the oxygen bonded like that. These are what we call carbonyl group. So these carbonyl groups are divided. There are a lot, but the common one used in this start are ketones and the aldehydes. Okay, so these are the functional groups that we'll be looking at in these structures. So the naming of ketones is derived from the alkanes. Suppose you have an alkane. Okay, suppose we have an alkane, let's say of carbon, let's say propane. Okay, but if now the carbonyl group is actually possessed at the middle of that chain of propane, you remove that E and you put prop prop, you remove that E, then you put um 1. All right, so that will be propanone. All right, so that's how we'll be naming these compounds. So the first thing that we need to know is that you prioritize ketones wherever, I mean, if possible, wherever you meet this compound. You need to prioritize this carbonyl group. Okay, so this is just a summary of your lecture notes, and it's important that you pay attention and listen to all the explanations. All right, so one thing that you need to do first, indicate the position. All right, indicate the position. Indicate the position of that compound. All right, I mean of the functional group. So that one is a must. Then replace, so just like you've been naming alkanes, but replace whenever like the substituents are involved, but replace that E from Ne. Okay, that E, remove it and add 1N. Okay, so that is it. Let us just look at some examples. And also one thing that I need to talk about, in cyclic, always assign at number 1, like always start wherever you see the OH bonded like that, let's say in cyclic. All right, so always start naming from that, then to there. So always start naming from a functional group. That's the information I want you to grasp. Let's go and let us look at some examples from your lecture note. Okay, so the first example that I have with me here is, suppose you have a compound CH3, oxygen there, carbon there with a carbonyl bonded there, then you have CH2 there, then we have CH3. How can we name this? So one thing that we need to understand is that first of all, what you need to do is first number first, but always make sure that the functional group receive a number, a list number. So from there I will say I will number from 1, 2 there, 3, 4 there, because if I start numbering from 4, I'll get number 3 at where the functional group is. So that is it. So we use this numbering 1, 2, 3, 4 like that. So now how do we number this? There are two ways of numbering, the new ones and the old Iipac nomenclature. So the first one you can use, either you can use, no one can actually hinder you from doing what you want. So first of all, you indicate at which position is the carbonyl group located. Okay, so the carbonyl group is located at 2, so I'll say 2. Okay, always we separate a number with a dash, then how many carbons in total we chain this but. Okay, so it's supposed to be butane. All right, it's supposed to be butane, but I'll remove the E at the end and I'll put 1. Okay, this is butanone. Or the other way you can write this, you say, okay, what's the whole, like what is the whole prefix of the carbons? You say this is but. It's supposed to be butane. Okay, but you remove that E and you put a dash, indicate the number at which the functional group is, then you always separate a number with a dash and put 1 like that. So that's how you can name this. That is it. So the other compound that we can do is, suppose we have been given a compound CH, okay, CH3, CH, CH, then we have again CH3 there on top, which is the methyl. Then now CH, not CH, but C with the functional group, the carbonyl there, of which always please this C bonded to oxygen, when it's at the mid, just know that's a ketone. At the end, that's an aldehyde. I'm sure we are very aware of that. Then we have CH. Let me put another group there, okay, so to make it interesting. Then again I have CH there, okay. So I'm always obeying tetravariant carbon rule of valences. If you have noticed, I don't make any mistake of leaving a hydrogen. So first thing, you look at this now, you prioritize again counting. You start from, are you going to start 1, 2, 3, okay, 4, 5, or you start from 5? If you start from 5, the carbon will receive at number 4, so that will be actually prohibited. So we want at least to receive a least number, okay. Even if I'm to start from here, 1, 2, 3, I'll still receive at carbon number 3. So there's no wound, there's no error like in that. You can choose either of the ways. So for me, let me start from here, okay. 1, 2, 3, 4, 5. So that is pent. But now I need to assign these groups. Remember, you start with the groups and arrange them in alphabetical order, okay. So now the groups that we have here, we have methyl there, all right, and also this should be a methyl. So that's a methyl there. Then the other thing that we need to understand is that, okay, we have a methyl there. So what else do we need there? What else do we need there? We have at carbon number 2 we have a methyl, and also at carbon number 4 we have a methyl. So what we are going to do is, we'll say, for us to name this compound, we'll say, alright, for us to name this compound, we'll say at carbon number 2 we have a methyl, so say 2, again these are just methyl, 2, 4, okay. You always separate. Since there are 2, I'll say di of methyl, so that will be dimethyl, okay. So dimethyl, then you can say, okay, you write this, then you connect to say, I have pent, okay. Pent, it is supposed to be pentane, but you remove that E and put a dash, indicate the position of, indicate the position of the functional group, which is the carbonyl. It is at carbon number 3. So you say 3, then you separate as a dash, then you say none, all right, which is 1. Or the other way you can write, you can say, okay, I'll write this group at in front there. That will be 2, 4 dimethyl, all right, dimethyl. Then I'll now include now the position. It is at carbon number, the functional group is number 3. Then you always separate a number with a dash there, a letter with a dash there. So that will be pentane now. Like, you just bring the normal one. So you choose. I feel like this one is good than the other. I feel like the first one is good than the second one. So you remove that E and you put 1. So that will be penone, okay. Okay, that is it. That's how you can name. That's how you can name the aliphatic these carbonyl or ketones. Then the other one, like, I can give is, suppose you are given a compound. Suppose you are given now a cyclic compound. Let's say, all right, you're given a cyclic compound. Okay, you're given a cyclic compound like that. Okay, so how do you handle this thing? So you start numbering again. So this benzene ring, I'll put this as a benzene ring. Let me just, the conjugation, let me put it as a system of rotating like that. So that's a benzene. So a benzene now will be considered as a group because it's not the part of the carbonyl group. Remember, we're respecting this carbonyl group. Okay, if the carbonyl group was just alone, you would have considered as a group, then consider the benzene or the phenyl as a functional group, as a main chain, or a parent chain. So what I'm going to do here, I'll start numbering from here where there is carbon. So I'll say 1, 2, 3 there. Okay, so naming this now will be naming this will be this now will be considered, it's at carbon number 1, this group. So that will be, when a benzene is a group, is called a phenyl. Okay, so at carbon number 1 we have a phenyl there. Okay, a phenyl. Then you indicate now the where the functional group is located at carbon number 1. Then you separate like that. Then you say, okay, this is propane. Okay, so it will be propane, but you remove the E and put 1 there. Okay, that will be propanone. So that's how you can name. Again, the other way of naming this, you can say, okay, at carbon number 1 we have a phenyl there, which is the benzene group. Then I want to include the dash this point, and what I will do is I'll say, okay, phenyl, then I bring the whole parent chain now attached. That will be prop. Okay, prop. Propan, then I'm not putting that E there, I'll put a dash, then indicate the functional group position, then light 1 there. So I feel like the first one is good. So that's how you can handle this thing. Suppose we have now another compound. Suppose we're given a compound again. Suppose we're given again the benzene compound where we have oxygen bonded there. Alright. Alright. Okay. Okay, so this is now like not just a compound, but it's just a cycle. So what I'm going to do is, at carbon I can see what's this, my aldehyde there. Then let me put a group there. Okay, so how do we number this? You start numbering from there. 1, okay, 2, 3. You always make sure that if there is also other group also should receive a smallest number as well if possible. So what you do is you say, okay, we start now at carbon number 3. You have a methyl there, so you say 3 methyl. Okay, just like we have been naming these others. 3 methyl. Okay, then this is a cyclo. Alright, cyclo what? It's a hexane, right? I mean, there should be 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, this is a pentane. Why? Because the functional group now is not considered. That group is not considered. Okay, alright, so say, okay, we have how many there? We have 1, 2, 3, 4, 5. Okay, 6. Okay, there are 6, so consider them 6. That would be a hex. Because if we consider, okay, wait, no, because we have the functional group there. We have the functional group there, and that's what is giving us function. Suppose it wasn't part, we don't have said pentane, so we'll write, I mean hexane, so we'll write this as pentane because the functional group is just there to act as, we don't consider it in the cyclic bond. Unless if the weight is okay. Let me just redraw so that we get a clear picture. Let me redraw this so that we get what we are saying. Okay, I think I'm confusing myself on how to read this. So let me write the exact compound there that we need to have. This is a hexane. Alright, so that's a hexane. Okay, okay, so let me put a double bond there. Okay, so that we differentiate with what I'll give you. So we put a double bond there, then the oxygen is bonded to O, then alright, then let me just name it now. So you always start numbering from here where there's a functional group, then 2, then 3, then 4, then 5, then 6. This gives us hexane. So at carbon number 2 there is actually hexane there. So what I'm going to do is I'll name this as at carbon number 2. At carbon number 2, that's where I've found the hexene, which is the alkenes group. So I'll say at carbon number 2 we have a cyclo, okay, cyclohexene, not hexane but hexene, okay, but I'll remove the e at the end and put none, okay, 1 like that. Okay, that's how you can name this. Or the other way you can say cyclo, okay, cyclohex, all right, cyclohex, you separate always a number 2 in. That's how you name the alkenes. Then from there again remove that e that you have put at the end. So you say e, you remove that e and you put a dash, then 1, then you write 1, okay, just like that, as simple as that. So the other one now, where I will say, since this one was considered as the parent chain, the hexane, because of its presence, now we'll do also for alkenes. Let me give you a structure. Okay, so suppose you have now alright, so let me put now a group there. So that will be, so we start numbering again from 1, 2, 3, because we want also the group to receive at least the number 4, 5, 6. Okay, so this is a cyclocarbonyl or cycloketones, which is just a pure ketone in nature. So how do we name this? So looking at this now, since there is no parent chain to actually proceed with the hexane, so the way we name this, we name it as, we have 3, alright, at carbon number 3 we have a methyl there, okay, at carbon number 3 we have a methyl. Then what do we do next? We'll say, okay, we have a methyl there, then we'll go to what is the name? It's cyclo, right? Methyl cyclo, okay, it's a cyclo. So 2 methyl cyclo, how many carbons are there? How many carbons there? There are 6. So cyclohex, okay, so cyclohex. So the hex now, yes, it will be a hex, but I'll remove the e and I'll remove the hexane. I was supposed to have hexane, but I'll remove that e and put 1 there. Okay, so that's how you can actually name that. So let's do something like something nice. Like, let me confuse now like these things. Like, let me mix them. Okay, suppose I have the methyl there, okay, then I have a functional group there, which is a ketone. Then I have again just an alkyl. Again I have an alkyl there. I have an alkyl there with bonded to hydroxide there, or hydroxy. Then again down there it says it's bonded is bonded to another methyl. This means that let me add another one there. Let me add another one there, another alkyl. Okay, so now numbering this, we'll start from, first of all, you periodize what we call your functional group. Okay, the functional group is now at carbon number. If you are to start, it will receive a list number when you start counting from here. Then that will be 3, that will be 4. I can say this is 5 and 10. So what I'm going to do is naming this. We'll start with how many groups do I have? At carbon number 4, I have at carbon number 4 I have a hydroxy. Okay, so that's a hydroxy. Then at carbon number 4 again I have a methyl. Okay, so which one comes later in the first in the alphabet between M and H? So you'll prioritize like that. Okay, do we have any other group? No, so the only group now is the main group. So what I'm going to do is I'll say, okay, at carbon number 4 At carbon number 4, I have a hydroxyl because H comes first than M in the alphabetical order. Okay, so that would be a hydroxy. Okay, then at carbon number 4 again, I have a methyl there. That would be a methyl. Okay, then now set the position of the functional group, which is our ketone at top carbon number 2. Then we say pent. Okay, it was supposed to be a pentane, but that will remove the E and put 1 there. Okay, the other way you can write this, you can say, okay, at carbon number 4 I have a hydroxy. Then at carbon number 4 again I have a methyl. Okay, then again this methyl now will attach it to say pent. It has pent, which is there are 5 it was supposed to be pentane, but I'll remove the E and put a dash and write 2 then dash 1 like that. That's how you can write these Iipac names, stuff like that for ketones. So there are a lot you can practice, but these are just your lecture notes. Alright, so this marks the end. Thank you very much. So watch out for part 2, where we'll talk about the aldehydes naming and special names for aldehydes and ketones at Raj.